Hey everyone, welcome to the video. Today I'm going to be talking about the volume of Earth. So we're going to be using the principle that the Earth is roughly a sphere. So what's a sphere? It's, a 3D circle. A sphere in real life will be like a basketball, I guess like a Pokemon ball, or a football. So that's roughly a sphere, and I appreciate the Earth is not completely spherical because you've got mountains, you've got valleys, you've got all sorts of ups and downs. So that's fine, which is why this is going to be an approximation. But something else to think about, which you may or you may not know, is that the Earth is spinning on its axis. So let's say you've got the South Pole and the North Pole. The Earth is spinning on this axis really, really fast. And because of that, it's actually slightly wider at the equator. So that's this red line going through the middle here. That's the equator. So because it's spinning so fast and you've got the centrifugal force, it's actually a bit wider here and less wide at the top. So it's a bit smushed down at the top and a bit wider on the sides. So why am I saying that? I'm saying that because the radius is going to be effective. So I will explain the radius in a second, but we're going to take the Earth's average radius of 6,371 kilometers. So for those of you who are saying, I have no idea what a kilometer is, 1 mile is 1.6 kilometers roughly. And I want to use a visual aid here to show you what a meter is. I do apologize if you can't see this, but hopefully you can see this. Now, this is a meter, and a kilometer is 1,000 of those. So you can imagine you've got 1,000 of those lined up. That is a kilometer. Just give you some sort of visual. So why is the radius important? Well, the volume of a sphere is this formula here. We have 4/3, so that's kind of just a fraction. That is a constant. You don't need to worry too much, but we've got 4/3 times pi. Now, pi is also a constant. It's used in mathematics to work out the area of a circle, the volume of a sphere, and it's a very useful constant. Now, that is equal to roughly 3.14, and we're just going to times everything by the, 4/3, the pi, and then we need to work out the radius, because that's what we're going to pop into this formula, because then we're going to cube the radius. So the volume will be 4/3 times pi times r cubed, which is the radius. So we've got the Earth average radius, and just to give you a visualization of the radius again, we've got r, and it's going from the edge of the Earth, which is the crust, and it's going all the way to the center, which is the inner core. So in case you are interested, the inner core is 5,000 plus degrees Celsius, so it's very hot, but it's actually still a solid because it is under so much pressure from gravity, and it's mainly made up of iron and nickel, and potentially some other things as well, but apparently it's mainly iron and nickel, and we want to go to the very center of that. So radius is from the crust on the Earth, which is where we are, lots of different layers to the middle, and then the very middle of the inner core, that's where we're measuring to. And again, as I said before, it might be slightly different where you're measuring from, which is why we're taking the average. So now all we need to do is put this average radius into our formula, and we can get an estimation for the volume of Earth. So if it wasn't clear, the volume is kind of the space taken up. So, how much space is it taken up in space or the universe? So I'm going to pop this into this little formula. So we'll do a little beep, boop, beep, boop. So I popped into my calculator 4/3 times pi times 6,371 cubed. So I'll show you the answer on the calculator. Now this might not make a lot of sense to you, but we've got, where would we go? 1.083. And then, so we've also got times 10 to the power 12. So I'm going to explain to you what this means. So our volume of Earth, volume of Earth is equal to, let's just make it more rough. So 1.083 times 10 to the power of 12, and this will be kilometers cubed. So one thing in maths is, and in other topics as well, if the number's quite big, and just for ease of, I guess, writing, especially in physics, if you get something that's really, really small, you might have it to the power of times 10 to the power minus something. But we're doing times 10 to the power 12 to kind of make it effectively easier to write, because you don't want to have to write down the whole number. But 10 to the power of 12, so if you can imagine a million is 6 zeros. So a billion is 9 zeros, and then a trillion is 12. So if you had, let's say you had a kilometer. So let's say you went a kilometer one way, so like this way, you went a kilometer up and a kilometer this way. So you're effectively making a cube that is a kilometer by a kilometer by a kilometer, a cube like a 3D square. And now you have to imagine that not only do you have a million of them, you need to times that by another 1,000, so you've got a billion of them, and you times it by another 1,000, so you've got a trillion of these big kilometer cubes. And we actually have slightly more than a trillion because it's 1.083. So this will actually also be equal to, same thing, just written slightly differently, 1.03 trillion kilometers or kilometers cubed. So you can imagine that's quite a big volume. It's hard to sort of visualize and understand. Maybe I'll do another video where we can kind of compare different volumes, but hopefully that makes some sense, even though I can imagine it's quite hard to sort of comprehend. But hopefully that makes sense. Hopefully it was clear. If you have comments or questions, I'll try my best to answer them. I'll get back to you in the comment section. But thank you for watching. I hope you enjoyed it, and best of luck with all your maths.